Hello. Hi, everyone.
Oh, hi.
How are you?
Good, good. So what time is it over there?
Here's 9 p.m. in
9
LA.
p.m. Oh my gosh.
It's a good
So,
time for beer.
so you're gonna go overnight, right?
Yeah.
Oh, great.
Hello. Hi,
Hi,
Casey.
hello.
Hi, Dongyun. Hi,
Hi,
Albert.
hi.
Hi, everyone. Yeah, I think we are still waiting for a few more people, so maybe please give around 5 more minutes. You can grab a coffee, water, beer.
I'm fully ready.
And water, unfortunately. Hello. Let's give a few more minutes to see, to wait for a few more people to join in. And unit tutors, please check if your students are all here. And yeah, let's give a few more minutes.
Hello.
Hi.
Apologies for the delay. Last minute upload to YouTube. It's good to see you guys.
I see. Thank you for joining from London. It's really early in the morning.
Yeah.
Sorry about that.
It doesn't matter. It's fine.
And thank you for delaying it 2 hours for us. I really appreciate it, both Tongyun and Professor Casey. Thank you.
No, thank you for agreeing to move earlier. I know Unit 1 was originally planned for a few hours later, and I really appreciate you guys agreed to switch it so we can have more interesting conversation, because you met the other tutors in the rehearsal. So we all thought this will be more beneficial for everybody.
Yes, I think it would be super fun.
Cool. Let's wait for a few more people. Taeyun and Dongyun, maybe you can tell me when everybody's here. Yeah.
Roger that.
Sure.
Cool. Yeah, so in the meantime, today we are aiming to finish the entire session within 3 hours. Let's try. And the order will be 2 groups of Unit 4, and then 1 group of Unit 1, and then 2 groups of Unit 4, 1 group of Unit 1, and after each 2 groups of Unit 1, we'll have a quiz session for with the paired group. And then maybe we can have a short break after the first pair. So unit 4 crit, unit 1 crit and break, unit 4 crit, unit 1, and then we'll have some more like general discussion. Yeah, and then we can wrap it up.
Yep. Unit 1 is all here.
Great. Cool. And also maybe before that, maybe unit tutors can maybe introduce to the other group what you have been doing in the unit over the last week of the week that we didn't see each other. So the students and the other tutors can have an idea of what you guys were working on.
Oh, right. Sorry, I should probably go first since I'm unit 1. Shall I begin, Hatsumi?
Yeah,
Yep. So
thank you.
our unit was about Mathematica, which was led by Dr. Chu-Heng Lee. He has taught the students for the first week regarding Mathematica and how to use various functions and features within the software, including the pre-trained neural networks to perform deep learning or machine learning in order to process images, data, and much more. And having taken that, we've asked the students to develop a project where they could take advantage of the efficient processing power of Mathematica and propose new visions as architects of systems. And we prepared a video each from our team, and I hope you'll enjoy it. I certainly did, and they've been working very passionately, so I'm very much happy to have witnessed that. Yeah.
Looking forward. Jason, do you want to add anything? You don't
Oh,
have
it's
to.
fine. Yeah, that's great.
Great,
Great
great.
introduction, right?
Cool, cool. Yeah, Donghyun, Casey, you can also add if you want, but Donghyun, maybe you can go first.
Yeah, sure. So our unit has focused on training the neural network from the image sets. So each team member concentrate on either cyclogen or the Stalgian process, that is the different neural network image training system. So in particular, cyclogen trains the neural network using two different image sets. For example, they use your building data that I get them as one training input, and use pictures they took near their home as second input. So by reciprocally learning the common features and differences between two image sets, the machine automatically transforms the images into new style. And on the other hand, in Stalgian process, students search images in social media such as Flickr, utilizing hashtag. So this method gave us a lot of chances to see how people perceive and recognize the society. The neural network was trained by the images we found in SNS, so the neural network could generalize the image style. So there are many things in both process that we could not fully understand, but I think it could give us new insight. Also, we takes advantage of different techniques such as photogrammetry and point cloud system to create three-dimensional model out of our trained images, both cyclogen and Stalgian process. Yeah, it's kind of a great introduction to our unit. Case, do you want to add something more?
That sounded good.
Great, thank you very much. Yeah, one more thing just before anything, all the students, please make sure you upload your files on the shared Google Drive. Okay, so we are going to start with Unit 4, and we we'll have two groups in a row presenting, and then we'll have a quick session. So Dongyu, maybe you can call the name out.
Yeah, I think Daniel could go first rather than the Albert and Carlos.
Okay, so Daniel,
Ready?
Albert, and Carlos will present, and then we'll have a short quiz session after that.
Okay, I'm just gonna share my screen. Okay, so for this project, I decided to focus on the facade of public squares, more specifically public squares in Latin America. So the idea behind this was to gather from Flickr images from 5 different public squares in Latin America. And the main goal was to sort of see if the neural net could learn some features from these areas in order to display something that they all share in common. And my approach was to sort of take these public plazas here, which are specifically located in Latin America, and pretty much center my Flickr search around these plazas and be able to pull images from Flickr from there. So for the data mining process, trying different tags. I focus on, wait, hold on, this is the PDF. 1 second. Okay. So for the data mining process, I focus on these tags, and the way that I started looking at this process was to sort of pick general tags and see what they would bring, and then go on towards more specific tags related to architectural elements. So one of the things that came out was by using more general tags like public square, plaza, or buildings, you generate a lot of images. The only problem was that there was also a lot of filtering that needed to be done after. And if you go more specific, there's not that many images generated sometimes, which it kind of relates to the way that people are in social media tagging their images in order to have other people view them, which kind of makes sense because they want to like put them out and catch a wider net as possible. So the search parameters included a time period of from 120 days to 4,380, which includes 12 years. Search radius from 1 mile to 20 miles, and the most successful was 20 miles to gather more images, but still a lot of filtering needed to be done. And after doing all this process, I gathered a total of 2,500 images. After going and pre-processing and filtering, I ended up with 1,400 images for the network. So one interesting part about it is that since all these pictures are taken from the perspective of a person, either a tourist or a local, they have similar sort of perspectives. And when training the network, you can kind of see some of the similarities as you get some of the sort of final generated output. So these were sort of the sample images that were fed as the training data set. So you can kind of see more or less typical sort of colorful colonial style architecture and the sort of perspectives and approaches that people take for these pictures. Some of them have faraway viewpoints. of like the whole plaza. Other ones have like just strictly frontal facade views, and others try to capture more specific things like details or specific sort of articulation in the facade and or other sort of architectural elements. And then once I fed those images into the style again, it would sort of train on those and generate these sort of fake images based on what it's learned. So these are kind of like, this is part of the training process here. And you can kind of see some of the features that it's picking up as it's learning as it's learning from that data. The first trial of doing a projection of the image on a New York City site that was given to us, it generates a decent sort of, I guess, repetition of elements that are somehow related to also the facade, but it also changes a little bit the style and also the perspective. It works well sometimes better at the ground level due to, I think, the high amount of images that were taken at the ground level that as part of the initial training data set. These are more projection images, so you can kind of see the variety of new image generation. One interesting part about this is that since there was barely any cars in the plaza images, when this image gets projected when this target image gets projected, it sort of removes the car and reveals kind of like a facade on it. So that was an interesting aspect of, depending on what you feed into the network, what it outputs. Okay, couldn't load the video, so I'm just gonna play it from here. So this was one of the projection images based on the data set that was given to us. You can kind of see some of the articulation of the typical kind of like colonial facades with the columns and base. It also kind of aligns in some things with the original facade. And another interesting part about it was that I decided to take a video of a house near where I live and sort of see what it would do, since this kind of has, I wanted to take it from a further away perspective to see if it could develop, I guess, a different type of image. And after sort of running this projection on it, it does begin to generate kind of like the wall of the sort of like the enclosure of a public plaza, but it also like in the same style of those buildings that it kind of learned from. So I thought this was pretty interesting, the way that the network kind of reinterpreted the foreground and the background. And it also seems like to keep the same foreground intact while adding some pieces in the middle ground. And in this video, this was after more epochs of training for the network, and you can kind of see that it does begin to develop more detail and is generating sort of more elements on the ground floor. So this video is actually more focused on like the street level, since some of the upper perspectives weren't working well. I wanted to see how it would actually generate the ground floor to see if it creates any sort of more three-dimensional spaces. You can kind of see again like how it doesn't sort of keep the car in, it kind of sort of goes over it and reinterprets like the facade. And finally, after having sort of created, having the network sort of learn all those features, we projected those images into a depth map. And from that depth map, it was able to generate a point cloud. And you can kind of see that it does, it's interesting to see that it does begin to resemble kind of like the ground plane or like that space in front of like these buildings and the plaza. And it also pops out some of those things, for example, people that are kind of like usually in the foreground. But it's able to sort of pick up on that, which I thought it was pretty interesting. I didn't think at first it was going to be as successful. I was curious to see that it is generating the ground plane, and then like the building has like the back facade of the space. So all these images here are actually generated through a latent block on the network. So these are kind of like created by the network itself and not projected onto another target image. So these are all generated from the network randomly. So you can kind of see that it does pick up some sort of image, some sort of features from the original training set. And that's all I have. Thank you.
Thank you. Let's move on to Albert. Yeah, and we will come back to your project later in the quiz session. Daniel.
Sure.
Thank you.
Just gonna share my screen. Can you see my screen?
Yes.
Yeah. All right. So my part was basically using another type of neural network, which is called a cycle GAN. And the idea was to take images of facades from Manhattan, which were in New York, which were on the right side, and try to go around my area where I'm staying, which is in Dubai. And I managed to get this type of style of building. I know it's a bit of an international style, but due to the pandemic, my range wasn't allowing me to go further than that. So the idea was to train a cycle GAN network to understand how the style of these types of buildings are and try to project them on a different type of facades of buildings. Now, basically, I had to use around 2,000 images from the Dubai set and around 1,000 images from the New York set. The training process took around 42 hours and it reached around 117 epochs. After finishing the training, I actually went and did some 3D point clouds, and I'll share my progress later. So these were all the images that were collected and trained basically from B to A, which is from Dubai to New York. And on the right side were all the images from New York. So basically, this network requires lots of images to train from. These are some of my observations throughout the training process. So the original image, as you can see, and the higher the epoch basically is, the more training the network has done. So even after 30 epochs, you can start seeing that the windows are actually starting to stylize like the New York style. The further you run the network starts getting finer details. So at the end, it starts getting more like finer details like the balustrades and the handrails. These are different angles and different images. You can still see at basically at epoch 30, the proportions of the windows are still there, but the facade is still on a different treatment. When you run it further, sometimes what happens is the whole design is actually inspired by different images, still from New York, but by different images. This was quite interesting for me, where basically it was giving me different styles for different trainings. It's the same data set, but the longer you run it, the different styles that you might get. What's interesting about all these images is it managed to keep the proportions in all of them. So the proportion of the building was maintained, although New York didn't have exactly this height of a building. It had a higher building and it had a lower building. This exact height didn't have, but it managed to understand that and portray it over here. Then it started learning basically on the ground floor that it needs to have some kind of a street from New York. You can see at the later stage where the street is, and you can see the lines for the pathway lines for the cars. One thing that I realized was that the network didn't understand, if you just give it an image, does not understand the images before it. So in this sense, it did not understand that the street is actually on a lower level. It directly takes the first two levels as the street, as the ground floor. So that's why you have the street on the facade over here. One thing it started showing towards the end, I don't know if you can see over here, even the signages from New York, this is a diesel sign, started showing on the facade. And this is another thing that I discovered, that due to the lack of sky in the New York pictures that were taken, it was difficult for the network to understand what the sky was at the beginning, but throughout different iterations, it started understanding it a bit more. What's interesting about these images, the further you train, the network starts understanding even ornaments, and it still subdivides the partition of the same proportions of the building. But the further you train the network, you actually start getting different styles even on different levels. And you can see ornaments and 3D of these columns from the outside are showing. You can even see like the mullions of the glass over here. So, and the brick gets more basically sharp. This is a quick movie to show the process. Okay, let me just play it from here. So as you can tell, it starts understanding the ground floor is actually retail. And the manifestation of the facade. One thing that I noticed was the network couldn't understand when the angle changes with the camera. It sometimes treats it as a different facade. So I think by further training the network, this I think can be resolved. But due to the time that we had, these were the results. These were very interesting, basically, observations for the facade. Also, the stone that's on the ground floor from New York started manifesting towards the end. You can see this looks like more like a New York style than the initial ones. And yeah, I mean, I think after doing this exercise, I think this provides a tool for architects to come up with different options and stylization for facades. I think this inspired me a lot and gave me some ideas that I wouldn't have thought by myself. And I mean, some of them are quite good enough to actually use in real life. And so so now we go to basically now we're trying to take a New York facade and changing it to a Dubai facade. So at the beginning, it understands the ground floor and the partitions and separations and tries to superimpose the Dubai style one. And then after around 117 epochs, it actually understands that this is the ground floor and adds some greenery, which was actually evident in the Dubai style buildings. One thing that I found interesting was that because the Dubai side building didn't have greenery on the facade, only had on the ground floor. When we were projecting on these staircases, it did not understand what the staircases were, so it thought they were greenery. But that was like a serendipitous accident. So basically, it started putting some greenery around the facade, which I kind of find somehow interesting. You can also see towards the end of the epochs, I mean, the geometry is much cleaner than before. However, you lose some of the initial formal language. So somewhere in between might be more interesting to use. It was kind of having issues when the camera angle was very acute, basically. Because I didn't have so many images like that. So, but at the end, it managed to do some kind of facade like that. Again, you can actually quite see even early on how it understands like how many windows are there and tries to build them up accordingly. And yeah, this is what I was talking about, having greenery on the facade. It's quite interesting. I find this actually more interesting than the final trained one. This is a very quick movie. Of how the training happened. And then basically after taking these images, we tried to do something called photogrammetry, which was due to the lack of training. The training wasn't that much done because we didn't have much time. So photogrammetry didn't give us amazing results. What we managed to do was point cloud. So we were taking the images and from the image, feeding it to a depth map generator, which creates a depth map. And from that, it actually creates a point cloud. So these are some of the outputs showing how the actual facade changes through time and stylized. I find them quite interesting, these animations. That's one. That's basically using a different image. And you can see how basically it starts to understand the ground floor, the street, and the signages throughout the training. And as my colleague Carlos said, that the ground floor, I mean, the plane, it starts understanding through more training. This was again another. And again, what's interesting is it's actually trying to project some greenery on the facade, which were not there in real life. But that's something that manifested itself with the training. And this is the final animation that I have. So it kind of starts understanding that the ground floor should become with more greenery and should look like, even it took the pergolas from Dubai and projected them from the New York. So the original image was from New York, and it was testing and projecting all the Dubai facade on that. And that's basically what you have so far. Thank you.
Thank you very much. We
Thank you.
also have Carlos, because Carlos and Albert was same group. So
Yes.
yeah, but we decided to separate the presentation as they're slightly different exercise. So Carlos, can we invite you to present?
Yeah, I'll share my screen. Okay, so the title of the exercise that we came up with is Polyvalent Settlements and Communal Expression. This is the style gun part of the exercise. To begin with, there's the development of the project to try to reach a more specific theme and ways to accomplish it. So there are two sides of this workshop. One is the social side and the other is the technical side. So from the social side, it was important to find a topic that was related to a contemporary social issue that could be explored through algorithmic design for its solution. And some of those issues that interested us were coronavirus, the coronavirus pandemic or similar emergencies, civil unrest and demonstrations that have been occurring lately a lot, also educational or intellectual pursuits of affected communities, and as well as artistic and communal expression. On the technical side is trying to explore the use of machine learning and artificial intelligence for architectural and urban design questions. And more specifically, retrieving data from social media sites. In this case, the use of StyleGAN, the management of large data sets, and if possible, 3D photogrammetry for its final representation. Now, the concept to integrate these two sides of the exercise is a space that is polyvalent, that allows for changing activities that can become host of several different programs, such as temporary clinics, shelter for people in need, ephemeral art spaces or exhibitions, even restaurants or shops. And for that, we need to find a style or an understanding of style that is about open plan spaces, abandoned spaces, decaying spaces, and spaces where communities express themselves, such as through art, public art, specifically graffiti. So the more specific, we have the following objectives: obtaining images from social media, from Flickr, according to specific keywords, following the desired typology of unoccupied, semi-enclosed or enclosed spaces, generating a style that is understood as an ambience rather than a set of specific ornamental or structural features, to try and project this style onto a typical New York architecture that was provided to us by the tutors, exploring this concept of polyvalency. And finally, also trying to understand the technical and conceptual difficulties of machine learning. So these are the final keywords that were used for the data set. The keywords came about trying to imagine how an open space that is that can be occupied by several different groups of people can be found through the Flickr. And that made for several searches directly on the Flickr site. And on the Flickr site, there are many groups and there are many specific hashtags or keywords that groups of people use to explore and tag certain photos that are elusive to this topic. So some of those are urban decay, I love decay, lost place, and urbex, and several combinations of those with more specific elements such as column or warehouse or place. Now, once the information was retrieved through the script, we found that still there was a large amount of pictures that didn't really that weren't that close to the goal that we set ourselves. For instance, you could see here in graffiti column, this is representative of how many of these images were accurate or close to this idea of an open space that's abandoned and that has a certain texture from its abandonment and from perhaps graffiti, etc. But still somehow clean and not overwhelmed by too much decay or too much darkness, which was the results that we got both specific results and obviously really unrelated results and everything in between. This is an example of other keywords, for instance, urban decay and urban decay plus column. And you can see that counterintuitively, if it was only urban decay, was actually getting, we were actually getting more images than actually specifying it a bit more. So these were certain findings that we didn't expect. And these are showing more successful keywords where many of the results were good to use. So the edit obviously included eliminating the duplicates through a script, generating most of the pictures following the same profile for the training to work, and also a lot of manual the elimination of particular images. So here are some statistics from those images, those data sets. It began with around 23,000 images, and then it progressively reduced until for the training, it was only 2,902. Here we can see images from the final set. So it's about semi-open or enclosed spaces that have an openness to them and a certain patina of use, but that aren't too busy with furniture or people or any other elements that would sort of delete the idea of openness that is needed for the concept of polyvalency. So here are the style gun reels once the training began. And from this image, this set of images, we could see that there is still an amount of, or a percentage of those images that that the computer is going to try and extract information from and turn them into style that we really didn't still want it, but it's just a learning process, right? Like we would have needed to edit further or retrieve even more data if we didn't wanted this large amount of non-satisfying images populating the data set. So while using StyleGAN, we start with like a file that is already trained, like a part of the training has already been done, using as a base human faces. So this is an example of that initial training. So this technique is called transfer learning. Once the training begins, we can see how the faces begin to morph into the set of abandoned open spaces. And little by little, the faces disappear, but still we can see a lot of sort of organic elements, which is very unexpected. It gives an almost surreal or parametric quality to the first attempts. Afterwards, that begins to be weeded out, and we get more regular images close to what was expected from the beginning. So as you can see, it progressively becomes the images generated by the training are close to what an open abandoned space would look like. And unfortunately, this was as much advancement as I could reach because of the editing and conceptualizing process. So I couldn't follow up with the project part, with the projection part. The next step was to project these images onto the New York architecture and get an idea of how it would modify it, and finally the photogrammetry. But some conclusions that can be extracted from this are like the management of large data sets. It's quite crucial for developing good workflows in terms of time, in terms of performance of the scripts. We should always try to specify clear and focused objectives to narrow our search, and also to appreciate the results, both the expected ones and the unexpected ones. In order to generate emerging or novel results, which is one of the main task of machine learning, it might be useful to integrate subjects that could be unrelated. So for instance, the organic elements from the human faces were producing images that were similar to parametric architecture or algorithmic architecture examples. And this was very unexpected. And also, well, machine learning in architectural design is a great expansion of current design procedures that can incorporate user or societal visions, expectations, needs in a more objective or seemingly objective way. So here's just a little meme about the machine learning prerogative. And that's it. Thank you.
Thank you. Thank you very much. Maybe Daniel, can you share your screen with the final video where you are training your own garden? And maybe we can shorten this discussion, like let's say in 10 minutes. But please, for all the other students, for the rest of the final crit, please keep your presentation within 10 minutes per team.
Sumin, so we're going to go after the discussion then?
Yeah, so there will be
Okay.
crit for these two groups first. Yeah, but let's have it just shortly. Just if I help kind of summarize these three different exercises. Daniel was working with the keyword of public square, and he was kind of getting the facade information from the public square in his public square facade, and using that to train the garden. Daniel, if you can just show that video where it trains the garden instead of this one. And
Okay.
yeah. And then what Carlos was doing is that he was struggling a lot to find the correct or more narrowed down search from Flickr. So what he was explaining is that what his journey was to kind of uh, finding and narrowing down the hashtags. So in order to get the right image set, that he doesn't have to remove too much manually. And yeah, Albert was very clear that he was just comparing the Dubai uh, and Manhattan, and then training the two different sets and comparing how this can be more inspiring for designers. And the main set goal for this unit was to try to use this kind of AI trained imageries to create 3D geometries and see how much we can push to use this technique in terms of architectural design. Yeah, here you can see that Daniel was training his own neighborhood garden, and then the resulting facade is changing into the public square kind of style. Well, any comments or questions from anybody, from students?
Well, if I may start the conversation, I absolutely enjoyed what the machine learning algorithm and photogrammetry is doing. I think the generation of 3D volume from the machine's perspective is super interesting, and especially when the noise, certain level of noise is introduced in the geometry, maybe that's a sign of less training perhaps, but I think it's super fascinating. I I think it looks beautiful, and it shows a certain type of a new landscape-like feature geometry that makes me also wonder, like what kind of processes the machine is going through to generate these shapes. And as for the themes, I think the themes were also very interesting. I also particularly enjoyed how the transition from Dubai to New York was so, it seemed so natural and yet so, how do I say it, almost in a very, very abstract, and feels almost unnatural and natural at the same time. I'm not sure I'm putting that into good words, but yes, I found that super interesting. I think this is generating a new imagery and new scenery that we haven't yet experienced, which is a whole new horizon. Yeah.
I also pretty much enjoyed the older presentation. I mean, especially like it's very different from the what our unit is doing as well. Like I mean, really appreciate that you could have like such a lot of engagement like from using SciGAN. And yeah, I mean, yeah, I can say that the all of three projects are really interesting, and the like Taeyun said, like it's like widened my horizon as well. And yeah, especially the for me, like the Daniel was like creating the square is, I mean, I think the previous video rather than this, I mean, it's like the end of the result. It was quite, yeah, fascinating to watch it.
One thing I feel a little bit shame is none of this exercise ended up with our like first goal of photogrammetry generated 3D model. But yeah,
I think.
But isn't Daniel made some similar like
yeah,
the goal
so
where
so yeah, because of the limitations, so Casey introduced another way of three-dimensionalizing with point cloud. So there was kind of, let's say, an interesting plan B, because this can also use the video, which in this project didn't show, but actually you can use a not a still image, but it can morph into different images, background images. So you can actually create like moving 3D models. But yeah, I hope maybe the next two sets of groups, one of them at least can show that.
Like this one?
The end part, the last part of
the point cloud part.
Yeah.
Yeah. Have any of you managed to make the point cloud with a moving animation?
I couldn't do it, like it wasn't working right, so I had to sort of use Rhino.
Yeah.
Just realized I forgot to put the perspectival projection in the point cloud generator. So everything looks like it's on like a ramp.
Ah, okay.
Sorry, guys. I missed a step. I was looking at, I really like the kind of public squares and the 3D forms coming out of it. And I think this would be something to kind of push further. Like, look at how we could start to work with these point clouds after they're generated, start to produce more kind of architectural form. But yeah, we should also just flatten out the ground next time. That's my bad.
Actually, for me, I really appreciate what you've done so far, because you got all process, you followed one kind of work site exercise from him. But I was just one question, and how do you feel and how do you get a sense while you're working with a machine and AI? No? That's just wondering. For
Like,
Daniel or yeah.
Oh, I never used sort of like a general network in this way, so it was kind of interesting to see, I guess, the whole process of training it and what it spits out in a way. What was really interesting though, it's kind of like with the data set where if you give a very specific data set, it's only gonna sort of pull things from that, and like you can kind of see here, like it pulls similar things with that, but then it also recreates something else, which I thought that was kind of like the most interesting part. The other cool part about it was that specific features, like for example, the car, since there wasn't any cars in like sort of the training images, it didn't really like keep them in like the projection images. So I thought that was like one of the interesting aspects where you can sort of be very selected in what you're training it to sort of have some expected outcome in a way. So I thought that was really cool. And it was a pretty interesting learning process overall. Even the 3D point clouds, maybe if it would have had more time to train the networks, then it probably would have generated like more interesting sort of volumetric spaces, and that would have been interesting to see too.
All right.
One thing I would add to that was basically what I discovered. I used to think that the more you train the network, yes, you're gonna get better results at the end, but the process throughout, I mean, sometimes an undertrained network, in my case, in some areas, gave me results which were unexpected and much more interesting than especially because when I had the Dubai facade projecting onto the New York. The Dubai facade was very strongly projected, which the end result wasn't much interesting for me. It was the process in between where you had different epochs where I found better results. So yeah, the end result might not be the best result. It could be the ones in between. That's my takeaway from that.
Yeah, thank you very much. We are running late, but thank you so much. And please, Albert, Carlos, and Daniel, please join us for the next set of conversation. Yeah, so we can come back to this conversation again. Yeah, so let's move on to Unit 1. And please, everybody, please keep 10 minutes maximum per team for your presentation.
Just before our team begins the presentation, I would like to paste the YouTube link to their video, just in case. Oh, yeah, one of our team members has done it, just in case, Zoom makes the video choppy.
Thank you.
So may I start?
Yes.
Yep, okay. So hello, so I'm Yeonjun from Unit 1, Team 1, and I will just start my presentation with our video. Right. Sorry. Oh, okay.
Do you have sound? If you have sound, you need to turn on the sound sharing option before you share.
Yep. Turn the share window to the program window and then change the sound setting, please. Sound output to
wait.
You probably need to share your screen again. Turn off your share screen.
Yeah,
okay.
Unshare, and before you share, you need to tick something. There is only two options. Just tick the option that shares sound.
Left bottom corner.
No, I mean,
I'm a bit confused about the order of the presentation. Sorry,
Relax, it's okay.
What?
I can help you to share the video if you want.
Yes,
please. Do you wanna play the video first?
Yes. Yeah, one of my team member will be sharing. Sharing it for me.
Okay.
Yeah, sorry. Okay, thank you for watching. And I'll just start my presentation now. Is the screen clear?
Yes.
Okay, so hello again. I'm Yeonjun from Uni 1 Team 1. So our project title is Urban Time Mapping. And the video was a fine summary of the work that we learned and applied in our project. So the inspiration behind this project is the monotonous cityscape of Seoul, static dimension, and the past existence of our urbanscapes are quickly forgotten. So our team's main concept focused on time and mapping. Thus, we try to implicate the meaning of time passing on building facade. We wanted to overlap the layers of time and process in between to enable a new dimension of time and form to emerge. So here this diagram shows clearly what our inputs are and what we're aimed for. So I'll be explaining the inputs and the process later on again. And it's just a summary, clear summary. And so this is our concept, this collage about our proposal. So our proposal is to create a dynamic facade, dissolving the idea of time onto the architecture idea facade. We have researched various functions in Mathematica in order to come out with inspiring images. We worked with the functions such as image restyle. This function is about one image following the graphical style of the other image. We worked with the weight of the variables to achieve the image that we desire. The most abstract and dynamic images were picked for further image transformation. Again, this shows the research we've done with different variables and functions. And again, we picked the most interesting outcome and did further image transformations. For doing this observation up to a certain level, we achieved the consecutive group of images, and we were able to generate, I have no idea why this is not working, but it's supposed to be moving image. Yep, sorry. So we were able to generate this kind of moving images within Mathematica. This page is showing the process and the trials that we've been through, and because of this number of experiments we've done, we could get various inspiring images using different functions in Mathematica for every single one. So these moving images show the potential of Mathematica as a powerful tool to produce images. So far, I have shown you the research that we've done that led us to the actual project proposing part, autoencoder. We restart the input images with prepared target images and output results of the autoencoder. In this process, past images were used as the input images, and the images that we were targeting were the photos of present time. We wanted to express the concept of time passing by interacting with three kinds of images. So there are photos from the past, predicted present from the past, and the real present time. What we used as an autoencoder is not a conventional one, but it was domain transferred. To reflect our idea, we composed the neural network to get the present time image as an output when we input an image of the past time. For that, the whole network is trained with past time images at first, and then the encoder part is extracted. The bottleneck layer is not a part that can be achieved from the previous steps. Therefore, it was manually designed and embedded between the encoder and the decoder. So, however, the output images were quite far from our expectations. So, in the aspect of generating one decimal numeric data from image inputs, it may successfully work, and this numeric data used for parameters of changing the volume of the facade, which I will explain in the later part as well. Okay, so explain further on the for the autoencoder. At the first step, past time images are utilized as inputs, and they are restyled by being affected by the paired present time photos. Then predicted images generated from the autoencoder also influences the restyling process of output images from the previous step. Using the image transforming functions, the time mixed images vary one time and the final output images are achieved. So as I explained in the previous page, as another way of showing the idea of time, we also try to change the volume of the facade going together with the mapped image. After taking numeric data from the mid process of the autoencoder, we put the data metrics into the elevation surface as parameters, combined with the first step. We could diversify the facade of the building and the surface of building elevation as well. So we are looking at the facade that has a moving image like the one shown in the video that we started with. So our team found this workshop very significant as we were endlessly challenging ourselves with a whole new tool like Mathematica, and we were able to convey our idea with this tool, which inspired us in so many ways. Thank you.
Thank you.
Thank you.
Yeonju, can you go to the best page, maybe?
The best page.
Yeah, your best page. Let's pick one. This one?
Yeah, maybe this one and the last one, maybe.
To be honest, I feel like this page, the moving facade looks a bit more interesting. To be honest, yeah. Like, okay. I mean, although like it's kind of obvious that you really like the circle image.
Yeah, that was the one of the variable that we played mostly, and which we found really interesting. How it changes its radius and the speed as we change the variables each time.
I mean, actually, yeah, to be honest, I'm a bit lost about that part. I mean, the why the circle image is really interesting, and then why does it show the potential of the Mathematica? Can you just explain it a bit more one more time, please?
So Mathematica already has so much functions and has potential for it to use for not only for mathematic, maybe something that's not imagery, but we so what we explored was its potential to be used for more artistic way, or it to be create something that is more inspiring for us, and maybe dragging that into the field that we were used to, which is architecture, as we were studying architecture, and maybe inspire us or be utilized as one of the part of.
Maybe I need to clarify my question again. I mean, I was asking like why do you think your circular image is how do you find about that is interesting for you guys?
Sorry,
maybe if I help, can you, Yeonjun, can you go back to a few slides up where you have a lot of different patterns?
Yep.
Yeah, this one. I think this is really interesting, and I think you on the left. I believe you are just changing something, and then you created the right patterns on the right, right? I think.
Yep.
Yeah, I think that's really interesting, and because of the like really fast results, I'm sure you like being very fast. It also means you can really intuitively engage with the parameters and values. This is something really powerful, you know, like in all the other software where when you are creating some patterns, like if the speed is really slow, it's very difficult to engage with it, and you just normally just accept what you are getting. And I don't know Mathematica that well, but just from this workshop, like from my kind of perspective, is that it gives you so much options in instant time, and I think you can like really so much more engaging with the different parameters and understand what exactly the parameters and functions are doing. And I was kind of wondering whether whether that could be like a bit more explored, and and also I really appreciate your will to bringing that into three-dimensional depths, and in a way currently it's more like 2.5 dimensional kind of extrusion. Still, that's not a problem. I was wondering if you can actually also try that in Mathematica. Instead of just exporting this and photoshopping, you know, like if you could have tried to generate even your diagrams or some three-dimensional mesh surfaces out of these images, but like by hooking up some more functions in Mathematica to achieve that, I think that could have been much more interesting.
Yeah, we were like keep
and
working
Yeonju,
and challenging ourselves.
Yeonju, you don't really have to like respond to all of these like questions or critiques.
Sorry.
No, it's not a problem. I mean, I really appreciate that, and I understand, and this should be more like a feedback time from tutors, and you can kind of use this feedback to develop your further learning, instead of trying to sell your project. So I'm more interested in hearing from other tutors, what is your kind of observation after you seeing this?
I think like, you know, one of the things we talked about in our section when we were having our more like kind of relaxed conversations was the role that like different types of algorithms played, and like where the machine learning algorithms or the neural net algorithms have value versus like other types of mechanism. I think like it's you know, it's really clear here like how much kind of generative and creative potentials you can have from like, you know, something that's more kind of parametrically driven, and as well as like the things that are coming from the more kind of labor-intensive processes of the machine learning. And it's, I think the more that I work with neural networks, the more like I begin to like the dumb AI, like the other forms of intelligent agency, like the ones that don't learn, that are like kind of explicitly coded or have like a really narrow understanding of the world that you're building into it, because their kind of stupidity and speed allows you to more like rapidly generate this kind of range of interesting outputs. So I think I can quite understand why this page is the one that's the most seductive to you. I think a lot of these techniques.
Okay.
Huh?
This one was my pick.
What was it? What was her pick?
Yeonju, can you go back to your pick?
Oh, really? This is my second favorite, so I can I just say?
No. What's your first favorite? I'm not so mean as to mean. I want to hear what you have to, what, like, you know, how you feel about this.
Maybe this one.
As I was assuming commented before, I was trying to break this into more three-dimensional kind of thing. So I was trying to kind of mapping it onto a mesh that is moving, as I talked in the presentation. But in this short time and with our very techniques, we were like trying our best to convey our idea, and I think it's kind of diagrammatically kind of worked out quite in interesting way.
Yeah, I mean, another thing that you could look at is, you know, some of the kind of transformations and things that you were exploring on your second favorite page. You know, maybe an interesting way of pursuing the third dimension. Like, I don't think there's any reason why you have to rely on the networks to produce the volume, right?
Mm-hmm.
So like a lot of the kind of algorithms or quick equations you're using for these transformations, you could begin to explore with the kind of z-axis as well to try to start to give some volume to these, you know, and it might have, you know, might get you to quicker results sometimes. Because it's always the difficulty of moving from the image to the form, right? So that in itself becomes a kind of whole territory of algorithm development for a designer. It's always an issue of like interpretation and translation, how you can begin to like place your authorship over top of these other forms of intelligence. It's quite nice, really great work.
Thank you.
Yunjun, I'm
Yes.
Chuheng. You
Oh,
did a
hello.
great job. Yeah.
Thank you.
Jaewon, I think your sound is breaking.
I think it's,
Yeah, I think it's Dr. Lee, no?
yeah.
Oh, is it?
Let's wait a bit.
Mm-hmm. No, it seems like, because for me, like Jaewon is talking, but yeah, I cannot hear any sound. Right,
Jaewon,
Jaewon?
are you talking? You are mute.
Yeah, we
why.
cannot hear any sound. It's very breaking.
Juheng's frozen, isn't it?
Was it Juheng? I thought it was
That's Juheng.
Jaewon.
Yeah. I mean,
It was starting to.
okay.
Oh.
Let's wait a bit. We can accommodate one more comment and we can move on.
Right. Can I say?
Yeah.
Can you hear me? Yeah.
Yes.
Okay. It's much more understandable compared to 2 days ago. Yesterday, actually, I really understand what you are doing finally from your kind of set of data sets. So it's a really great job, and I like the circle run, you know, even in your background. So thank you.
Thank you.
Can I pick my favorite? My favorite is this one. Cool. Good job, guys.
Thank you.
Yeah. Any more comments? Shall I move on?
I'd like
Oh,
just
yeah,
add like
sure.
yeah, let's just add just I mean just this compliment, like this is such a good, I mean lots of progress like compared to like 2 days ago.
Yeah, definitely was a good move to really focus on experimenting with the algorithm. Yeah, instead of focusing
I'm back.
on. Oh, hey.
Oh.
I'm sorry.
Great.
Yeah.
Yeah.
Can I give some comments?
Yes, please.
Yes, please.
Yes. It was very impressive in such a short. You explored many functions of Mathematica, including neural networks and mathematical functions. And the one point which I really like is you designed your neural networks by yourself. You made a two autoencoders, and you made a kind of a neural surgery, and you made your own creative neural networks. So in machine learning, the most important part is collecting data. But for you, in such a short time, you could not make data collections and message them. So yeah, I love that network architecture, and I hope you could finish this work with enough data. So my best pick was your background image in circular ones. Yeah, it's kind of art. I love that. Yeah. So I'd like to ask you, how was your experience with Mathematica in such a short time?
It was very interesting for me. For me, it was my very most first time to kind of experience this kind of computer coding material, and because Professor Lee was being so helpful and so helpful with giving feedback, and we were kind of actively asking questions to you, and you were keep giving us feedback and solutions, and it was very interesting and intriguing, and I love to keep explore this tool further.
Okay, I love that. Good job.
Thank you.
Good job. Thank you. Thank you, guys.
Thank you.
Yeah, let's
Thank you
move
so
on,
much,
but
Miss.
we can come back to this conversation at the end again. Yeah. So students, please hold on and please don't leave. The conversation will go on. Yeah. Next group from Unit 4.
I think it's the Juhong's turn. Are you ready, Juhong?
Probably some technical issue. Jung, are you there?
Oh, I cannot hear Donghyun's sound. I'm gonna share my screen. Can you show my screen?
Yes.
Okay. Sure. Unit 4 in Juhong. Actually, my teammate is Soyeon Kwon, and that too, she's busy because of her job, so she's not here. Now we're gonna present it all of our process. We're gonna try to use CycleGAN and StarGAN about.
Sorry, Jung, can you full screen, please? You can Control L. Thank you.
We use CycleGAN and StarGAN to extract the Korean signage buzzard. And actually this is about Korean signage. Until a few years ago, there's a lot of law related to signboards in Korea. Thus, the facade of building did not match the city landscape at all. And the signage board were shaped like follow pictures. And recently, many of these type of signboards have been disappearing through signage maintenance project by each local government. But there are signs that have yet to be overheard, and those are green, the Korean landscape. But if you think about it from a different perspective, you may think that is also a Korea culture, we think. And this is a cycle GAN training. I used the cycle GAN to change Manhattan building to Korean signage facade and to change Korean signage facade to Manhattan building. So those are data that we input to A and the B. Actually, these are the pictured by me in Ansan. So that building have a lot of facade that we cannot count how many of them. So I choose this building to train B. And those pictures are the training B to A that Ansan, Korea to Manhattan. Actually, those images are A to B, that Manhattan to Ansan, Korea. So we categorize images, those things, that we put the 5 images to tasks. So and those are the category images that training A to B, that Manhattan to Ansan, Korea. So I'm gonna show you the videos. Those images and videos are the B to A, that Ansan to Manhattan, that Korean building changed to be Manhattan building style. So what's the video? Not gonna work. I'm sorry. I have to open my another file. Okay. Oh, actually, this is the origin pics, and they changed to be those things. This is test 2 image, that origin. And we can see that those facade is not kind of Korean style. So this train is a little bit successful. So some of the signage changed to be column or another walls or windows, something, etc. Yeah, this is the train B to A, and I'm gonna show you A to B. A to B is that I already mentioned that Manhattan building to Korean signage building training, but I'm gonna show the video. actually those things are not what I expect. So I think that the neural network that recognize the signage as a color or something, not as signage. So those training is a little bit fail. So actually, I expect that those facade gonna be something signage shape or like those things, but A to B is not gonna work. So okay, then this is the cyclogram training. Actually, I'm trying to find some Korean signage building image in Flickr. So I put the parameters to search like those things, but actually there are amount of images over 5,000, 6,000, but I removed all of unuseful images. Then I just get the images with 66 like these things. So I have to change the way. So I'm trying to collect the images by myself. So I use the road view that neighbor maps road view. So I captured all of Korean signage things. Then I captured images. I collect the 1331 images to collect. And actually, if there are more time, I can get more images, but there are lack of time. So, and I trying to use target training to the images that collected by Flickr and Naver road views are trained by Stark and Collab codes, and they train the data set which was collected with the base images like this thing, and change that basis to similar image of data set that is like Korean signage. So watch the video. Yeah, the faces changed like those facades, and I think these images are a little bit successful. If there's some more time, I can get more sharper images and get more details of those building things. So, but I have to presentate, so I stopped the training and still doing my process. So like these things look like signage. When I get those images, I think, oh, those are the Korean style, I think. So those are a little bit successful. And I project those things to Manhattan building. So I'm gonna show you a video. I think previous training is a little bit successful, so it's gonna work like Manhattan building changed to Korean signage style, but like these things or some of images that looks like Korean signage style a little bit, but many of images are not gonna work. There are something changes with facade, but those are not what I expected. So yeah, that's the projection of star again, and I do make the PT cloud render. So we train the data that made with Stargain training with mono depth collect codes. They're gonna extract the depth of the images. Those images are one of input data and depth data. So these images two that's yeah, the depth data of this image is these things. And then after training input data that like left image in the last page, this one, with monodepth data that like right image like the last page, this one, output result gonna be this star file with XYZ and RGB code. When I open in Rhino 6, the top view is like this image, but another view, you can see those things are all a group of points. So then make all of pictures to the video, and we can see the collects of Korean style signage building that made by AI. So watch the video. Yeah, actually, these videos not likely what Casey doing, Casey's job. So I expect more changes with set points or something, but yeah, this is the result of our projects. Thank you very much.
Thank you. It was great. Let's move on, and then we have a quiz session. Maya, are you ready?
Yep.
Maya and Kirti.
Can you see my screen?
Yes, we can.
Yep.
All right. Good afternoon, good morning, good evening, wherever you are. So before we start the presentation, a small caution I would like to say is you might need to hold your seat tight because you are gonna enter the world of spiritual enigma. Have you ever wondered how a hybrid style of Gothic and modern building will look like? Have you ever wondered how a style from Indian classical temples and sculpture will look like? I know it's difficult to imagine, so that's why through spiritual enigma, Kirti and I will give you a glimpse about this world. So as you can see, we use CycleGAN to create that hybrid style. On the image on the left shows the trainee data, and image on the right shows a church, which is Gothic style in my town. This is a backend process, how the training was working. As you can see, the image on the left was able to pretty quickly get features on the training compared to image on the right. It was because my training B data had very simple features compared to training A data, which had many sculptural and other articulate forms. So it was, so sample B to A was able to quickly adopt those features compared to sample A to B. And as you can see from this image, this is a very unique and hybrid style which is created from Gothic and modern combination. The image on the right, you can see how the columns are creating a unique side of symmetry which the Gothic temple has never seen before. It even identified the depthness created in the balcony in Manhattan training data, and it created these perforations which church never imagined. In this, you can see how the windows which are in Gothic shape were converted into rectangular forms which were inspired from Manhattan. And inherently, you can feel the Gothic style in this hybrid form because of there are some instances of Gothic big window which you can observe, but a lot of horizontality has been added in this hybrid style. As you can see, this is some samples of the training data. There is another thing which this unit hybrid style has adopted. So many buildings in Manhattan have a retail space beneath and a residential space above. So the new hybrid style has adopted this ornamentation, which differentiates how the top program is different than bottom program. And you can see in the third image, a really interesting ornamentation is being adopted, and also a unique rhythm which one can never imagine. Can you hear the sound?
No sound. You need to reshare your screen with the sound sharing option turned on.
You can't even hear right now?
No, so you need to unshare your screen first on Zoom. Yeah. And when you're sharing, there is a tick box, share sound.
Oh, got it.
Cool.
Should I also take optimize screen for
No,
video?
don't do that.
Okay. Can you hear now?
Yes.
Interestingly, I cannot hear that sound. All right. This is not the image I want to. All right. So this is a photogrammetry model which was created using the hybrid style. So just to confirm, the sound is coming, right?
Oh, from here.
It's okay. So as you can see, it created this kind of point cloud, but because of this hybrid style, there were some features on the map. It was not able to identify whether it's part of the facade or it's projecting on the facade. So then it created this kind of unique projections in this image. And this is kind of interesting because when there was a style transfer, no one was able to imagine whether a point cloud map would look like this. So this was an interesting exercise where if you see in the model, there are columns and those ornamentation inherent in this point cloud model. Right. Then I was experimenting how I can use this point cloud and play with the texture of this mask, and if there is any interesting way I can use that. So is the sound running?
Not now. Yes, I can hear something.
Is it?
Kind of.
Oh, okay. Give me a second. You hear now?
Yeah.
All right.
Not when you full screened.
The whole experience is not getting communicated. All right.
That's weird.
1 second. Can you hear the sound now?
No. Let's just play.
Okay.
Maybe better just full screen and play the video without sound. Yeah.
Okay. As you can see, all right. This is giving me a hard time. Then I hope the sound works now. I'm gonna complain to Microsoft. Yeah.
This works.
This was 2.5 point cloud morphing exercise with basic audit. I performed that on the style transfer image, and you can see how the volumetric play the new of the style created by the all right. This is, you can see parallelly how the image transfer was working. So it might not be simultaneous because there are 2 frames which were missing in my style transfer. So it might be a bit long. This was hybrid Gothic modern style. Right. So I worked on cycle game, and now Kirti will present style game.
Thank you. Great. So yeah, that was the last 2. So to recap, Juhong was working on the signage in Seoul, and Meyer was working on the Indian spiritual temple, Gothic, that kind of style, right?
Yeah, so Kirti will now present the...
Oh, you have more presentation? Okay.
Yeah.
Okay, can you guys hear me?
Yeah.
So, so as Mayur was telling, I was working on style GAN and he was working on cycle GAN. And so we took the topic of Indian temples. So what was more appealing about Indian temples is that its geometry is very self-recursive and follows the principles of fractal cosmology. So it's very interesting how like the whole temple in itself is formed of uh, like its small units are actually the whole entire temple in itself, like the principles of cosmos, and that is sort of spread across a large area in India, and each temple has its own distinct style in different parts of India. So the diversity was what was of interest, and we wanted to see how when we feed these images to AI, how it interprets and interpolates these kind of relationships and the tectonics. I'm really sorry for that. Yeah.
Gertie,
So
can you full screen, please? And if you can speed up, that would be great.
did you say speed up?
Yes. Yeah.
Yeah, so as this also reminds us of Malevich's tectonics and the fractal geometry. So one of the most interesting things that we were looking at is the morphologies of temples, how it varies across different regions. So which was one of the factors for deciding how we pick the training data from Flickr. And another one was the details and how these uh, ornamentations are sort of adding up to the whole yeah, so this is a picture of the original data that we were using, and I think my PDF crashed. I think I'm unable to play videos on my PDF, so is it okay if I play them separately?
Yes.
Yeah, so I'm sharing my video.
Gertie, do you need help? Do you want to send your files to me? Or Mayur, do you have Kirti's file? Maybe you can share.
I don't have access to those files.
maybe there is some technical issue. Meyer and Kirti's teammates. So Meyer was working on the CycleGAN part, and Kirti was working on the StyleGAN, and Kirti was looking at the building up the data sets that are towards that Indian traditional church, right? Temple. Sorry, temple. Yeah, maybe I guess Kirti is probably restarting or something. But maybe we can go ahead with our create session, and maybe when she's back, we can let her present. So to recap, Juhong, maybe do you wanna maybe share your screen just for a while, and then Maya, you can also share your best screen afterwards. Yeah, Juhong, I think I also really appreciate the work that you tried, and really it was really rigorous, and I know that you have like really clear goal that I want to just change the Manhattan into like Korean signage, and you said this is not successful. But I think they are kind of really interesting and colorful, and I quite liked it. And maybe, yeah, so like if you go to the next page, yeah, maybe you are being maybe a bit too early. Yeah, these are beautiful. Maybe you're being too early to judge what is successful and what is not. But I think, yeah, this is like really interesting ways of like it gives just such an amazing sets of colorful images that you didn't expect. So I think, and that's something what computer thinks that's Korean signage style, isn't it? So I think it's quite interesting. So you don't really have to say this is not successful. Of course, it didn't do what you probably was imagining, but that's a little bit too straightforward and literal. And these kind of things that you don't expect that you will be able to do by just imagining, I think that is the beauty of using these tools, and misusing it and finding what's kind of create what kind of creativity you can use out of it. And for Maya, I think I really appreciate that at least you managed to make a photogrammetry model, and you are also using a lot of different lightings, trying to show the kind of maybe organic beauty of what you made, you know. But I think also, but that specific model was generated from a lot of very loose control of the input files. So it's generated by the photogrammetry model with very little input. So maybe it's a little bit too early to like kind of, you know, just accept what's giving you and just absorb the error beauty of the errors. But I wish this could have been taken a little bit further, and maybe try to analyze which part was extruded more properly. So it's kind of kitchen and egg thing. Like you shouldn't have a very specific goal, but you shouldn't also just accept whatever a computer gives you. And it's kind of difficult balance. Yeah. But I think as a first attempt to generate 3D model and out of these sets of images, I think that is, I really appreciate that.
Thanks for your feedback.
Thank you.
Yeah, I mean, I think like quick workshops like this, you should just be like experimenting. I quite like that you actually were not embarrassed to show your crazy this like blob failure or whatever we want to call it, because I think it's cool.
Yeah,
And you can build from it, you know. I think I'm really glad that you went that step, and also were able to get the other kind of 3D techniques working as well.
Yeah, and actually you showed that video morphing in the point cloud model, so that's also really good. Any other comments?
I mean,
Taeyeon, thank you.
yeah, I would say I totally agree with the previous comments by Sumin and Casey. Mayur, I think you've done a great job and a very interesting work. I love this morphing video. And I must say I did really like your confident attitude while presenting. I think that that always makes it a more pleasant experience. Although, yeah, maybe just on a side note, maybe when something doesn't work, maybe you can find ways to go over it quickly for your partner or the other people who will have to present. But anyways, that aside, I think you've done really great work. Like all the other people were enjoying, like I very much enjoyed the video. And yeah, I think you put it together wonderfully. Uh, and and the Indian theme was very nice. I really like the theme as well, since I'm always interested in Indian architecture, and I think you managed to bring that flavor out really well with your project in a new way. This is super interesting. And my comments to Ju Hong would be very much the same as Sumin and Casey. What I'm glad that you were brave enough to show your results that you consider as failures, but you know, like they have already mentioned, they don't seem like failures to me. Like I consider process to be part of our work, and I totally agree in the sense that it's a very interesting result that I think could be a motive for an inspiration to all of us. And yeah, it was great to see your experimentations and all the efforts. Yeah, I think Kurti is ready now, right?
Yeah.
Yeah, sorry for that.
Kirti, you ready?
Yeah, so this is how the training went about for the using all the temple image sets, and this is how this is one of the walk through the latent spaces between the neural network. So this is, you can see how like there's a really diverse.
Sorry, Kirti, we are not seeing anything.
I think you must share your screen, not just okay.
Yeah, I can see something.
It's fine. It's fine. Yeah.
So there's a lot of like diverse geometry being generated, and like all different temple styles from all over India. And this is another one. So there's a lot of details as well as sculptural details, as you can see in 3D. Like when it's transforming from one point to the other, I think it gets really hazy and gets a little crazy in between. But otherwise, the forms are quite interesting. And and then I used that for generating some projected videos. Um, so one was from the LA dataset. So as you can see, I think it was identifying the hierarchy and relations between the like the organization within the geometry of the temple, and that's why it was creating a lot of branches and uh, sort of fractal like geometry onto the facade, which was otherwise a simple plain flat windows that we see every day. And this is Manhattan, and here what was also interesting is it was forming those spires on the top of, again, flat rectangular buildings. So that was quite interesting, and definitely like it was picking on the details from the temples and trying to put that on to the facade. I mean, if I would have gotten more time to train the model, the details would have been more sharper. And it is also picking up the colors from whatever. And I'll just finish with a few images. Yes. So these are few still images if you want to look at like the detail in the models. And a lot of branching. So this branching actually happens because a lot of temples kind of have a lot of trees around them, and trees are also considered very sacred in here. So it is always like a symbiotic relationship with the roots, and I mean often it also damages the structure, but those aesthetics were also captured and I was quite impressed with that. Like the tectonics of the temple versus the branching growth, organic growth observed in nature. That was quite interesting. And yeah, I think that's it. Thank you.
Thank you. That's great. Let's just have a few more minutes of feedback on these three projects, these three presentations.
Sorry, so are we going ahead?
Let's give Kirti a bit of feedback.
Oh, right, yeah, of course. Yeah, I was about to say, yeah, like I was commenting to Mayur, I think, you know, I think the fact that you both paid attention to what's nearby and, you know, paid attention to Indian heritage and showed us what it's about, and, you know, really use that as the main ingredient to bring out this really authentic Indian flavor, and mixing it with machine learning, I find that super interesting. Yeah, I mean, I always find it interesting, and it's always difficult for us to capture what's right next to us, and we tend to miss it. But in your case, I think, you know, like you managed to find that right next to you, even though it's next to you and in your surroundings, you managed to find the gem that you show. And I think that's wonderful. That's a wonderful attitude as an architect and as a computational designer, I think. So I really enjoyed it.
Thank you.
Yeah, I think you got some very like detailed results out, right? And some of the latent walk were looking like very compelling reproductions of the temples. I think what will start to become interesting is like how can you push the mechanisms or kind of rework the machine to produce something that's, you know, like other or like different from what has come, but that's maybe another step after this. But you did a good job of like kind of figuring out how to develop a data set to get a kind of a very polished result at the end.
Thank you.
Great job. Yeah, let's move on with Unit 1. I realize we didn't take the break time, but as we are running a little bit late, so if you need some toilet break, you can pause your video and go grab your things and everything. But we are not going to have a specific break time. Unit 1, last group.
Yes.
Are you ready?
Yes.
Yeah, great. Yeah, great.
Hello. Hello, this is
This
Jane. And let me start with your video, please, and
Wait.
today's presentation.
Hold on.
There's a giant echo here.
Okay, yeah.
We're not getting any sound. Do you think you can fix that?
Sorry for the
technical issue.
Can we start at first?
Can we start at first?
Like from the beginning?
Thank you.
I think we're getting echoes.
Hello, this is Tun. Can you hear me properly?
Yes.
Yes, thank
Yeah,
you.
sounds good.
Yeah. Uh, did you enjoy the video? We are Team A of the Unit 1 session, and our project name is Pixel Tsunami. So let me start. In the beginning, our topic is started from Han River, which is passing through Seoul and still playing a central roles in Seoul. Recently, the Han River has changed, and we wanted to compare today's artificial boundaries of the rivers and alternative boundaries that are generated by the algorithm. So to do this, we use Mathematica, which is one of the easiest coding tools, and we visualize an artificial tsunami with the pixels moving. This diagram shows how the project proceeds with one river's image as the input, and we made the mask for making the boundary of the function's application. And with the input image and the mask with the input image and the mask that we made, we use in-paint function to combine them. So this is our key function of our project is in-paint function, and in-paint function fills empty parts of the damaged image by using machine learning. Before explaining how we use the function, we set the total variation, diffusion variables, and max sample values to detect the river image distinctively. So let me start the process how we use this function. So first, we wrote source image with image function and set this as img variable. And second, we clustered elements of the source and recolored with the clustering component function. In this section, we set the variables to 6, which means the number of the clustered group, and we can see the differences of the clustering element group. And third, we make a mask with the image with clustered components by select component function. We can set the liber element parameter to specify the weight the function is applied. And step 4, we remove the noise to get more clear masks. With closing function, and we set 15 as the value of the noise parameter. When the noise parameter is too small, we may not able to get the proper image due to the noise. If the noise parameter is too high, the result can transform too much. And step 5, we extracted mask by changing the radius variable. I is the radius variable that you can see, and we changed the radius variable from 50 to 600, increasing by 100. And for getting more suitable mask, we combine the extended boundary mask and river shadow figure. And finally, we use the in-paint function that we explained before with the input image and the mask that we made. To show them in more realistic manner, we use the blend function with manipulating function to join all the results. So this is how how the Han River tsunami looks like. The river expands depending on the mask boundary that we set. So the video which I showed at first, you can see that we applied this method to many other rivers, but not all trials were successful. These are the observed issues that we want to talk about in this session. First, for the East River in Manhattan, the function recognized Central Park elements as the river part and made the whole waterfront as a continuous green network. And there are some clusters of buildings in the middle of the green. And second thing on the right side of the slide, it is Malaga Cove Resort. And we can see that machine learning generated a natural looking topography under the sea. And sometimes machine learning generate the island by itself. So the water turns out to be the island in the Chicago River resort. And in the result of the tourist beach trial, we can see a huge parking lot along the beach, which may be generated according to the road elements within the city. So these are little failure experiences with this function in paint function. These are something you can create with Mathematica. There are multiple we found cool but need further research and experiment. For example, we use the image restyle morphological component solved by an image feature track functions. Yes, you can see. So let me introduce the result that we made. With the image restyle function, we could transfer an image feature into another style, and you can see the original images and original image on the left side of the page. And with Mathematica, you can be like Van Gogh as well. So this is the image restyle with the Han River image and the Van Gogh picture. And morphological component function, it allows us to detect what is connected or not by its pixels position. And we use also sort by function, and it could sort element in list and comparing each element listed by the pixel value. So you arrange the pixels of an image that in the way you want. And image feature track function, which is literally track features in the image. And we try to detect the wave movement for generating a more dynamic tsunami. So all those functions in Mathematica is simple, and we use the Mathematica for generating a lot of to generate a lot of results. Yes, that's all we did. Thank you. Thank you for listening.
Thank you.
Thank you.
Such a great presentation. I mean, it was quite straightforward, and like, yeah, I really like the your work, and it's really quite straightforward, and it's really grateful to see the your further research as well. I mean, it's, like, I think you explained very well about what your research is, and then what the Mathematica can do. And yeah, I mean, I really enjoyed your presentation, and yeah.
I agree with Hanjun. What I really liked about it is that in paint function, I really didn't know that even if I met, like, I knew your project from like 2 days ago or something. I really like how that function is made for the Photoshop problem, you know, like you need to mask out something that you don't need in the in the in the image, but you actually use that tool and made it into a design tool. And I think this is really meaningful. And that's what exactly what we wanted to discuss, the potentials of certain tools, how they can be used as our design tools, you know. Like, I think you exactly did like the unit, like literally what unit 1 was like about to deliver. Yeah, so it meets the brief really well and very well presented, and like step by step gave us a very clear tour of how you developed your learning curve and what was failed, what was not working. I think that was also really well explained. Very good job.
Thank you. Is there any questions?
Yes, it was a very nice tour, Mathematica in the tsunami. Yeah, you
Right.
coined the term. Yeah, pixel tsunami. I love that term. Pixel tsunami itself is very creative. And I think you explored many image processing functions of Mathematica, and you combined them with InPaint as a kind of pre-process. And I felt that you a bit mastered kind of image processing functionalities of Mathematica. So it's time for you to enjoy more functions of Mathematica for your research. Very good job. Great.
Thank you for your really kind tutorial for the Mathematica. It's really helpful to explore the functions of the Mathematica. Thank you for your instruction.
Yeah. Very happy to hear that. Thank you.
Actually, I want to say that with just one function, InPaint function, it's not really, we couldn't get the good results just with the one InPaint function. So we tried to combine another functions to manage the data more properly and more properly job. So
yeah.
So in
so
this
maybe,
slide,
please, yeah.
In this slide, in the tutorial of the InPaint tutorial, how to use the InPaint function, there is just say that with this function we need to expand the data for detecting other like around data, but we thought with along that tutorial, we need to detect only not for the river data. I mean, with the just InPaint data, the function detects other data except
I see.
the river things. So we combine other functions as well.
Actually, your example may be the most difficult example for me to utilize InPaint. So your problem is, very difficult one. Usually InPaint is used for the very simple case. So maybe in the future, you can combine multiple modality images like kind of high data or different types of information can be combined to detect more features. You mentioned that some green areas and green rivers cannot be differentiated with InPaint only. So actually in Paint is a kind of machine learning function, but it's a very classical one. So in the future, you need to try deep learning. So I expect that you have a difficult time to find proper parameters for, right? So
Yeah, we
but
spend a
in
lot
deep
of
learning,
time for that.
yeah. That's the problem. So, but in deep learning, if you got enough data, that kind of manual parameter search can be very reduced. So, anyway, it's a very nice try. So next time you can jump up to the neural network things. So, please.
Yeah, I think we all understand this, that you didn't came up with this result with one button. And you also explained well that you are also using this mask to try to also control the erosion, for example. And there must have been a lot of back-end functions that I understand that it's not just one button creation. And when I see your image, you also have also the urban area is getting changed all the time, isn't it? So that probably was also some kind of problem for you. But I think what's really meaningful here is that you set up your own agenda and problem and try to resolve that with the given tools. And I think that's more meaningful
right.
than we kind of say, oh, this is not just coming from one button. Of course, we understand that, but people will understand that from that keyword. It was using that in paint function, and you managed to erode the river. But of course, there will be a lot of other problems. And how do you keep all the urban areas in consistently, or how to control the erosion more precisely, and all these things. I think that's an interesting problem and task. That's a design task that you set up by yourself. I think that's really, really well done. That's what we want to see in these kind of workshops.
Thank you.
I mean, I do think it's a tiny bit of shame that because I really do like their video. I posted the YouTube links to both teams' videos in the chat. So if any of you have spare time, I'd appreciate it if you go and check it out, because they did grind their souls and time, effort, and body into making all this. I think you guys have come a long way since Wednesday. I've been with you through the night, so I think you've done an incredible job. If I can, yeah, just a personal note.
Yeah, well done. We were all watching. I was watching on YouTube because the video was not playing well.
Same here.
Yeah, so I think it was a great session, and I think I want to actually spend the rest of the 20 minutes to maybe have a bit more like free discussion time. Maybe doesn't have to be specific to one project, but maybe if students can also kind of turn on your video and have like join our conversation a little bit. To maybe start with, I want to ask everybody one question, but you don't have to talk about this question. We can talk about anything, but maybe each tutor or student, maybe can you share your kind of understanding of social algorithm? What is social algorithm, and what is the future of the technology and tools and the relationship between human and technology in our society? But it's a free talk. I just wanted to ask this question to moderate the discussion, but you can also talk about something else. Anybody volunteer?
Okay. Before I talk about social algorithm, I'd like to say about like machine learning stuff. You know, like as you know, the famous architect Aldo Rossi, right? He say, "I do not invent. I just remember." He said that. So I'm really wanted to see what machine remember it and what image return it. So because it's kind of hand-off design process, right? So in that sense, it's quite interesting result came out. I mean, I feels like some image, it looks like Francis Bacon's painting and early work of early Mondrian works like that. And also it looks like a impressionist kind of painting over there. So I feels like you know, like when you look back the history of art, history of painting, right? Compared to the architecture, we miss Baroque style kind of design. I mean, because architecture is very difficult to realize, and I mean the dissolved figure or ambiguity kind of thing. But I'm found like those kind of 3D image from AI kind of, you know, like design process. So it's quite stunning for me. So I accept those kind of things. And then in terms of social algorithm, I have no idea. I don't know. You know, like a beehive, you know, bee, they have their society and they must have their own algorithm to act like certain way. I mean, those kind of things over there. So I don't know, but can he really hack it or can he really understand that things? I'm not sure about it, but at least you have to try it, right? So in the sense, I quite interesting terms, social algorithm. Okay, that's it.
Thank you. I don't know can be one answer as well. Yeah, so free talk.
What I think is, like, as an architect, like, we tend to be more creative and bridge ideas across disciplines uh, to find that creativity which was not done in the past. So the way I see artificial intelligence and using machine learning is finding patterns and combining them, which even the machine doesn't know or we humans don't know. So let's say I search a hashtag on Instagram. There are 1,000 different images. We can maybe find a pattern which is very evident. But what if when we feed those 1,000 images to computer, it can find like the social attachment, why people are getting attached to those pieces and identify that pattern and also mix them and pleasantly surprise us in a creative ways. This creativity through social.
Um, Actually, for me, I had a quite good experience in this workshop to understand how we can work with the computer more than just doing something with the computer. So, but also I quite liked finding some social media by clicking by getting some by flickers kind of stuff, which is kind of one of the way of meeting social and computational thinking together as first step. But I think I would like to say a little bit more about what kind of social media effect more effect on the our proposal. But I think we couldn't reach that stage because we don't have time and we just learn everything. So I think it will be the next step for us to do more to do, I think, setting up the more about what kind of social aspect or social behavior or social, I don't know, but social as like a social media, social concept itself in order to deliver the some algorithmic or computational thinking together. So that could be the, I think, next things for us. Yeah.
Thank you. I remember like few years ago, maybe we were also having like similar discussion about how to work together with algorithmic agenda and social agenda. And I remember Jay was asking me, why do we have to mix? And then I was a little bit kind of shocked at that time.
But still, I'm thinking that, you know.
Yeah, yeah. But because what I thought is, well, like if you understand the potential of the tools, then it can be it's something that you can, it's usable for everywhere. So I didn't think it's like particularly something like very specific. I thought it's a tool that is given to everybody, and if we understand it, we can, as architects, to set up agenda as the last team was setting, and then we now know how to use it. Like if you understand it, we know how to use it, then we can kind of set the agenda, as that's what human can do. Computer cannot set agenda. Yeah, but I like this year. I think it's quite amazing that all our tutors were kind of like really into this and being, you know, to be honest, like I really appreciate like Jay or also June was, they seemed like they're coming from computational agenda, like as if like the tutorials and everything was, yeah. Also because our maybe topic was very tool based, but I kind of, there was few moments that I kind of think, should I give up? But this year, I kind of felt that the time we were discussing and engaging was not wasted, and actually, all the tutors are really engaging and like wanting to know the potential, and I think that is something really valuable. As the directionality of this group of people and the agenda. So I think there are a lot more potential that I can see now. Yeah.
Uh, yeah, I want to add one more thing. Actually, in this workshop, I try to, I don't know, but I try to erase myself more. Actually, and then even I didn't really get some term from your side actually, but I think, but from this workshop, I realized that in machine learning or AI are not just tool, not just tool. I realized. So
Yeah.
this is not a tool. It's kind of, I don't know, working together with us. I feel that. So I think working with a robot or maybe AI or machine will be the part of social life later on. Maybe. So it's kind of a big momentum to think differently. So it is, I think, time to, I don't know, maybe it is time to rethink what kind of dimension or levels we can achieve later on.
Yeah, I think it's a paradigm, and also this doesn't mean that it erases your agenda. Like there should be something to build up, and yeah, there are so many things that this can harmonious work together with a lot of different things. But there are a lot of kind of stereotype or like discrepancies how people look at computational tools. Like they think computational tool is just beam or uh, making a curved architecture. You know, that's not everything. Yeah. So yeah, maybe I want to have maybe students also opinion or other tutors. Yeah, feel free to jump in.
Come on, Unit 1. Nobody? Really?
Well, personally, I mean, I just think that just one thing just came up in my mind. I just personally, I think it can be really easily compared to with when the first time AutoCAD came up, I guess. Like I mean, like before that, everyone was trying to draw all the drawings by hand and then using the rulers and those kind of things. And then at the beginning, like even though the AutoCAD came out, like people were thinking like, do we really really need to use this, or like I mean, is that any other function that's just drawing the lines in the AutoCAD like that? So we can I just feel like we can simply compare that times, like, so for now we are like the very easily can approach to the computers and then all the tools, and then it's all about how can we use it, and then how can we approach the function, not just function, like how can I say that the agenda of the tool set itself, like. I mean, it just came up my mind, and I just want to say that. So I mean, yeah, for example, like like when you use the smartphone, for example, like well, there's lots of things you can do with the smartphone, but however, like I mean, it doesn't do everything for it automatically, and it's all about how you understand and then how you use the tools and sort of things.
I also want to kind of, maybe I'm changing the topic a bit abruptly, but I think Mayur also mentioned this in the comments and while he was speaking. I really enjoyed the fact that I'm actually now a bit glad that we really switched to discuss with Unit 4 agenda, because I could find a very good common ground where we are approaching this machine learning aspect not simply as a strict matter-of-factly research or as a simple analysis tool, but we also speculated in terms of art, and we do trial and error, seek to find meaning in those noise data, let's say. Seeing those kinds of potentials open up, I think really opens up a new horizon for a new discussion where the machine learning is not in a strict sense is meant to serve us as a tool that simply throws us answers, but also gives us new potential to cooperate, coexist, and work together to create a new type of work. And I found this very inspirational. I was inspired by my students, if I can call them that, by the participants of Unit 1. They really showed me what could be done in such short amount of time with so much passion, as well as the works of Unit 4, which was also very much inspirational. And the morphing typologies and the morphing point clouds and all the machine learning that you guys have performed. I especially love the mistakes, and I thought those were really amazing and super fascinating.
It's very interesting to see some of the machine learning work and see the features. And in, after experiencing something in this workshop, I feel like in the architecture discipline, there is some the limitation of the machine learning, and actually I think that comes from the two-dimensional limitation itself. But I feel like if we could collect some of the three-dimensional the model in some of the common platform, it's gonna be just some of the time-consuming the things that emerging of some of the automation of the building or some of the architecture stuff. So I just want to see some that kinds of thing in your future, and I'm just looking for what the machine learning will be able to do something in this architecture field.
Thank you. I know everybody's dying. Let's have just few more comments from maybe students.
Come on.
Come on, jump it in.
I'm gonna call out names.
Sorry, can I?
Oh yeah.
Can I comment? Yes, I just want to say I'm really thankful to the tutors, like as well as I thanked our Dr. Lee about the tutorial. Also for the second week, the tutors were being so supportive and morally and technically, and yeah, without the support from the tutors, we wouldn't be able to produce this quality of work. And yeah, it was really meaningful experience, and I just wanted to say thank you.
Thank you. One more.
Just want to say, thank you to Casey that share your ideas and codes for your what you gave us. So actually, it is really hard to follow up because everything is new techniques for us, especially to me, and I just want to say that really thank you.
Yeah, it was great working with you. Hey, sorry, Sumin, I'm like slowly drifting towards like.
Yeah,
like
I know. I'm
past my
trying to wrap
bedtime.
it up. Yeah.
I'm getting like lower and lower in the chair, but
Yeah.
I just thought like, like something short like this, like we jumped into a ton of stuff and I know it was kind of overwhelming, but I think even more than learning the techniques, you start to understand like the kind of realities of these types of things and to kind of like what is a social algorithm. These types of kind of feed forward intelligences are more and more responsible for driving our behavior on a day-to-day, minute-to-minute basis in terms of the way we engage with apps, the way that media is presented to us, the way that we engage with politics and communication. And I think that like if one thing is that the workshop maybe has shown is that you should be incredibly suspicious of anything that's been trained in the past, right? This issue of inductive stagnation. So I think Meyer's question is quite good, the one about the should architecture reflect culture or society? And I think maybe another question is what are the traps of algorithms which are defined by the information that precedes them? Right? Like where are there opportunities to produce like a new future? So, the machines that we're working with that are actually controlling the way that we vote, engage with each other socially, engage media, are defined by the patterns that have come before. Like will our behaviors ever actually change? Which I think is a really interesting problem that we're dealing with a ton in the States right now in terms of our media system, and like how it's become a kind of really specific thing. Like you only see the media that already reflects the ideas that you hold to be true, and it creates this kind of very bizarre perpetuating divisions of people. So anyway, I think that you can see like it does a really good job of making Indian temples. If you showed a lot of Indian temples, can it do anything else in that? That's a good question, I think. Good job, guys. That was a lot.
Yeah, thank you very much. Thank you for all the tutors, like their tremendous work and effort. Also, all the students doing such a good job with all these days and nights. Tell me.
No, I just like to add that there, really thanks to Casey and Juhang to joining the social algorithm this time. Yeah, I mean, I'm so ashamed that I couldn't catch up the Unit first tutorial yet so far, but yeah, I'm going to watch it later, and then I'm very excited about it as well.
Yeah, thank you all for your time for joining this discussion as well and being with us for until now. Yeah, unfortunately, it's getting really late here, so it's better to wrap up. Yeah.
The real question is, what time is it where Albert is? Like he's video up, probably 6 in the morning, 5 in the morning.
No, now it's actually 11 today. You started late. Usually it was always better.
It's better. Yeah, today was
man.
better for Albert.
Yeah.
We got it right on the last day.
but really, it was very interesting, the workshop. And one of the things that I found nice about it was the first week where our minds were open to the 4 different workshops. I mean, I've never heard of Mathematica before this workshop, and it was a very interesting. I mean, it's like a very interesting software to learn. And yeah, the ideas of every unit was quite interesting. The whole, I mean, I'm very grateful for all the tutors, and I think you've organized a great workshop. And looking forward for next year. I don't know if it's gonna be digital or online, or it's gonna be in person. And let's see. Thanks all. Thank you all.
Thank you. Thank you all. You can also join our second session with Unit 2 and 3. All the students are encouraged to join. Yeah. But
5 hours later, yeah.
Yeah. Casey, yeah, you can go to sleep. Guys, really good job. Thank you so much. Yeah, and yeah, I hope to see you again next year.
I mean, don't worry, there are a bunch of zombies over there, so they must be joining next session.
Yeah. One more thing, just please submit your InDesign package. Everything that you showed today, it has to be uploaded with all the raw video files. Yeah, just to tell you, if you don't submit, we are not gonna give you certificate. Yeah. So please do that. Thank you very much. Good job,
Thank you very much.
everybody.
Thank you.
Thank you.
Bye.
Thank you for all the wonderful work.
Thank you.
Bye.
Thank you. Thank you all the tutors.
Good job.
수고하셨습니다.
수고하셨습니다.